Hello YouTube!
Hello!
Welcome to Undergrad Robotics.
We have something great to show you today. We've been keeping our programmer locked up for about a week now, and he's finally produced some good results.
You've come up with a motion tracking algorithm.
And we're going to show it to you live on the screen so you can watch and learn and see how this works out.
So stay tuned.
Black magic.
Right, so in order to detect motion from a picture we get from the Pixie, we have to first convert it to grayscale. So we get the Pixie image in with red, green and blue values, and we just add them all up together and divide by 3. So we have a grayscale picture now. So what we do is we take the previous image and compare it to the current image. The image has an object. Imagine this is an object moving to the right. So what we do is we compare the pixels in both images, and we end up with this little picture here. And this is the black and white version, where the black pixels here represent motion, and the white pixel represent no change. So what we want to is to draw a rectangle around this object here, and in order to do that we have to do some motion or object separation algorithms. So the picture is analyzed from left to right on the x-axis first. So we move along here, and when we detect the pixel change, like this pixel right here is changed, we save that pixel into a new object that we have a value for top left xy and a value for bottom right xy. We add this xy value here into both of these at first, and then we plus or increase the size by 1. So we move along here, and when we detect a new pixel with the change, say this one right here, we take all the objects which has already been detected, and we make a bounding rectangle around it based on the top left and bottom right, and we add 2 to each of it, so that we get like 2 pixels around the previous object, and we check if the new pixel that has been detected is within that rectangle. So in this case this pixel right here isn't. So we make a new object from this one. So we keep moving along on each pixel, and when we detect a new change, say here, we can immediately see that this pixel belongs to this object, and then we increase the size of this object by 2. And we continue analyzing the picture. And now that we detect a new change here, we can increase this object's rectangle by 2 more pixels, since this one is now within this object and it has increased the bounding rectangle. And we can see that this pixel also belongs to this object. So this whole object right here has an even larger bounding rectangle now. And we keep doing that until we've separated every pixel in the picture, and yeah, we have a list of objects. Right, so when we've completed analyzing the whole image, we have a list of objects that has a value for top left, a bottom right, and for size, where the size is based on the amount of pixels contained within an object. So we then go through this list and we find the largest objects based on its size. And then we calculate the center point based on top left and bottom right. So let's say we have an object here that is the largest object we could find. We then use the top left value and the bottom right value to calculate the midpoint, which is around here. So we also have the center point for the image, which is located in y100 on the y-axis, and x160. So kind of hard to write upside down here, but bear with me. Next we calculate the vector going from the middle of the object to the midpoint of the image. This vector we're going to use to control the motors in the rig so that we can steer the object into the center of the image. So yeah, that's basically it. Right, so I hope you liked our explanation of how the motion tracking works, and you can find the code for the Pixymon program that we used in the demo you saw earlier on GitHub. The link will be in the description below, so I hope you like it and check it out.
Yes, and this week we have also done some 3D modeling and spent hours and hours with rendering, so we have some cool graphics to show you. And we also created a kind of nice, very small power distribution circuit board. So we're gonna give you a write-up on that as well.
You can read all about it on the blogspot as always, and yeah, see you next week.
Yeah, bye.
Bye.